Good morning. This is Unit Inequalities, Intro to Inequalities. This is Lesson Unos. All right. Why did the cell phone get glasses? Because he lost all his contacts. How did the mobile phone propose to his girlfriend? He gave her a ring. All right, today should be kind of a review, so let's get started. An equation uses an equal sign to show that both sides are equivalent. I will zoom out after I write all of these. And blank an inequality shows that both sides are not equal. So an equation has an equal sign to show that both sides are equivalent, and an inequality shows that they are not equal. Now, you may be thinking, well, they can be equal because it can have that line underneath it. Well, that's true, but they're not actually equal because one side is still greater or less than the other. They still can be equal, but it also is greater than or less than. So it's not completely equal. That's why inequality is different. All right, our signs, greater than, equal to. We know the line goes under it when it's equal to, so line underneath. And then the not equal, this is fancy, y'all. You're going to put an equal sign and then a line through it. And they also can be, this is not on your page, but they also can be equal. Why is Santa so good at karate? Because he has a black belt. All right, I'm going to pause the video and let you do A through E. I'll give you about 1 minute. Ready, go. Welcome back. The answers to A through E. 4 is less than 9. 0.5 is greater than 0.45, which we wouldn't really say 0.45. We would say 45 hundredths. So on B, 5/10 is greater than 45 hundredths. On C, -3 is less than -2. On D, -6 and 1/6 and a tenth. -6.1, which is -6 and a tenth, is equal to -6 and a tenth. They're the same thing. And E, 12 and 4/10, so 12.4, is greater than 12 and 4 100ths, 12.04. All right, I am going to pause and give you about 1 minute to do the next two. You're going to write them just as you would say them. So it'd be 6, and then however you would say it. So I want you to write exactly how you would say it. I'm going to give you about 45 seconds, maybe a minute, minute and a half. Ready, go. Welcome back. There's 2 ways to write each one of them. You could read left to right, or you could read right to left. And I'm going to write both of them. Reading left to right, it would be 6 is less than or equal to X. The other way to write that, the other way, would be X is greater than or equal to 6. You only have to write one of those, but I wrote both of them. I'll zoom out and let you get it all in just a second. Next one, Y is less than 5/10. You wouldn't say 0.5, that's not the technical way. Or you could say 1/2, since 0.5 is 1/2. So you could say 5/10 or 1/2, either one of those. The other way to write that would be to say that 5/10, or you could say 1/2, either one, is greater than y. All right. Moving on. Use the variable as the starting point when reading inequalities. So on 1 through 9, it wants us to sub in the value that they gave us and see if it makes it true or false. So I'll do number 1 for you. So it wants us to take 11 and sub it in for k. So I'm going to place that in. I'm going to go 11, and then we'll go plus 8. Is that greater than or equal to 19? So then I'm going to kind of work that out. 11 plus 8 is 19. Is 19 greater than or equal to 19? That is true. So I'm going to give you just a few minutes to work out 2 through 9. I'm going to work out number 6 for you before I let you get started here. I'm going to take 5 and plug it in for x. So I'm going to go 6, plugging 5 in for x. So I'll put it around parentheses, plus 5. 6 times 5 is 30, plus 5 is 35. Is 35 less than 18? There's my steps, by the way. Is 35 less than 18? No, so that is false. So I took 5 and plugged it in for x. And when you plug it in, you can put it around parentheses there. All right. Why do I put 5 in parentheses? Because parentheses mean multiplication, and 6x means 6 times x. That's why I put it in parentheses. All right, you work out 2, 3, 4, 5, 7, 8, 9. I'll give you, 3, 4, 5 minutes. Ready, set, go. Welcome back in. I'm going to plug 3 in. Is 12 greater than just greater than. Is 12 greater than 3? That is of the true statements. Is 3, plugging that in, is 3 greater than 3? No, they are equal to. It is not greater than. So number 3 is false. Number 4, I'm going to plug 13 in for C. So 13 minus 12 equals 30. Some of you may be wondering, why did you not put that one in parentheses? Well, I could have. What number is butted up next to it? It's understood to be a 1. What is 1 times any number? Itself. So there's no number butted up next to it, so I didn't need to do the parentheses. All right, anyways, 13 minus 12 is 1. Is 1 greater than 30? I don't think so. That one is false. 5. 16, is it less than 22 minus 8? 16 is less than 14. Is 16 less than 14? No, it is not. So that one is false. Again, why did I not put this in parentheses like that? Because what number would be butted up next to it? A 1. And so 1 times any number is itself. Okay. Already did number 6, so I'm going to go down to 7. I'm going to plug 5 in for J, so 2 times 5. Why did I put it there? Because I have to put it, it's butted up next to 2, so I need to put it in parentheses so I don't multiply. 2 times 5 is 10. Is 10 less than or equal to 8? That is a false statement. going to plug 6 in. So 5 is butted up next to R, so I need to put the R, which is 6, in parentheses. Now go ahead and work that out. 5 times 6 is 30. 30 minus 3. 30 minus 3 is 27. Is 27 greater than or equal to 25? Yes, it is. That is true. 27 is greater than 25. And on the last one, I'm going to plug 8 in for M. So 6 times 8 minus 12. That is 48 minus 12. That is 36. Is 36 less than 40? That is true. That is of the true statements. All right, to the back page we go. There's all of them. I'll give you about 1 minute if you did not get any. Where do werewolves buy Christmas gifts? The beasts buy? What did the snowflakes say to the road? Let's stick together. And why did the turkey join a band? We all know that one. So he could use his drumsticks. What's a math teacher's favorite winter sport? Figure skating. All right. Back page. Inequalities can also be graphed on the number line. So inequalities also need to be graphed sometimes, which we've already kind of touched on this. To have a closed dot, it needs to be greater than or equal to. Same thing with less than or equal to. It needs that line underneath it. If there's no dot included, then it's just regular greater than or less than, which we talked about last week. All right, so let's graph this one. We're going to start at 5. Open dot or closed dot. It's going to be a closed dot. Why? Because there is a line underneath that. Which direction is it going to face? Well, let's think about it. X is less than or equal to 5, so it's going to be the numbers less than 5, so it's going to point to the left, the less than side. Now, there is a little trick. If the variable is on the left, you can go with the arrow, whichever way it's pointing. That is only if the variable is on the left, and I'll show you in just a second. I'll do number 10 for you, and then I'll also do number 11, and then I'll let you go to work. All right, so let's do 10. K is greater than 11, so we're going to find 11. We're going to put an open dot. Why is it an open dot? Because it is not equal to. Which direction shall it go? K is greater than 11, so all numbers larger than 11, so it's going to go to the right. Also, we could go with the arrow right there, so we know it's pointing to the right. Number 11. F is 12 is greater than or equal to F. So if we're going to find 12, we know it's closed dot because it's also equal to. Now, if I went with the line, I would do not copy this. If I went with the line, it is in yellow. Do not copy the yellow part. I would point that direction because that's what the arrow says. But let's restate the question. 12 is greater than F. So F is actually less than all 12s. So if I were to put the F on the other side, it would be F is, I'm going to read it backwards, F is less than or equal to 12. Now look which way the arrow is facing. It's facing the left. Okay? So you can only use which way the arrow is facing if the variable is on the left. If it is not on the left, you got to use your brain. All right? So there it goes to the left. F is all numbers equal to or less than 12. All right, I'm going to let you do 12, 13, 14, and 15. I'm going to give you about 2 minutes. Ready, go. Welcome back. 12, let's work it out. It is going to be open dot on 6, and it is going to face the left direction because D is less than 6. Next one, 25, open dot, and it is going to be all numbers less than 25. The next one is a closed dot on 0, and it is actually going to be greater than, so it's going to flip, because you need to put the variable on the other side if you're going to use that strategy we talked about earlier. So it need to look like that. And the last one, 4.5, is somewhere right in there, and it is all numbers greater than 4.5. So it shall look like that. Okay. All right. Let's go down to 16 and 17, almost done for the day. The McDonald family spends no more than $150 for groceries. Well, let's no more than. That also means equal to or less than. So no more than means equal to or less than. So how are we going to graph this? So first of all, let's make our equation, or inequality, excuse me. Let's use M for the McDonald's is less than or equal to, because they do not want to spend more than, so that is less than $150. Now your graph can look like a bunch of different ways you could count by tens, you could put 150 here and count by tens. That's not the way you have to do it. You could count by ones, you could put 150 right in the middle, so you don't have to do it that way. You could do it this way, you could put 150 here, and you could count by ones. Okay, it's really, as long as you got 150 on there and you're counting by the same thing, it really does not matter. So we're going to put a closed dot on 150, and M is less than or equal to, so the arrow is going to go that direction. All right, 17, Gerard. I wonder if this is the Subway Gerard. By the way, what's a firefly's favorite dance? The glitter bug. All right, 17. Jared earns at least. So at least is another way to say more than or equal to. At least is another way to say more than or equal to. So Jared, so we're going to use a J, wants to earn at least. So he wants to earn more than or equal to $10. So again, let's graph it. 10. You can go by count by fives. It really doesn't matter. Let's put our 10 offset. So let's go 10, 15, 20, 25, 5. He wants to earn at least 10. So he wants to earn 10 or more. And it would look like that. All right. Off to your homework, because that's all the fat guy in the guy's back has for today. I'll see you on the flip side. Adios, amigos.